Humans, hi! Direct variation. Mathematical. Let's explore. Whee! Okay. Here's what this business is about. You've got two variables, x and y, and they're said to be in direct variation provided that y equals ax, where a is equal to 0. So actually, it kind of looks like this, right? It kind of looks like y equals mx plus b, but with no b. Okay, so where a is known as this idea of the constant of variation, and we are saying that y varies directly with x. And that's how you would speak about this direct variation. Okay, not a big deal, just some definitions. Okay, let's make some more sense of this. We've got equations here. We're going to say whether it is or is not direct variation and what is the constant of variation. So in the first example, I hope it's obvious, but you already have it in the form y equals ax, where the a is matching up with this 5. So 5 is the variation of constant, or constant of variation. Reversed. All right, this next example, 2x minus 3y, equals 0. We want to make it look like it's in this form here. So we could move this to the other side because y has to be on one side and x on the other. So let's do that in order to avoid negatives. We've got 2x is equal to 3y. Well, we've got to get y by itself. So let's divide 3 on each side. And it looks like 2/3 with x is equal to y. I hope it didn't mess with your mind, the fact that I just moved the y on this side. So the constant of variation for this second equation would obviously be this 2/3, and yes, it is looking an awful lot like this equation, so it is direct variation. This last example, let's get y by itself by adding x on both sides. When we do that, we've got y equals x plus 4. Wait a second, that's not in this form, y equals ax, so therefore this equation is not direct variation. Now, direct variation does have to do with lines, but we know lines to be used when we're talking about this equation, y equals mx plus b. The only difference is there's no b out here. Well, what would be the b then? If there were a b here, what would its value be? 0. There's nothing there. So the y-intercept for these direct variation equations is just 0. What does that mean? It means that all of these equations of this form, y equals ax, always go through this point here, the origin. And it also means that this number right here, this a, is your slope. So the y-intercept is always 0, 0, and the slope is whatever the number a is right here. Okay, so if a is bigger than 0, that means that your slope is bigger than 0. That means that it's some fraction where there's a number up here and there's a number down here. Well, if both numbers are positive, that means we're going up some distance, whatever it is, and we're going over some distance, whatever it is. And if your point here is always going through the origin, we have a line that looks like it's going up from left to right. Therefore, its slope is positive. If we have a number a that's less than 0, that means your slope is negative. Because this number, when you have a fraction, something over something, the result is negative. And with slope, let's assign that negative to the top number. That means we're going from this point here, we're going down some distance, 1, 2, I don't know, some distance, and we're going over some distance. When we connect those dots, it looks like your line is falling as you go from left to right. Interesting. Okay, so let's do some math. If you have an equation graphed at the right, you have just the graph of it, and it goes through, this line goes through -1, 2. We're tasked with writing the direct variation equation just given this picture? Well, if it's direct variation, you can tell because it goes through right here at the origin. So this line appears to be direct variation. So here we have y equals ax. We know this is true, this formula or this equation about this line. Okay, well, knowing that, oh, we also know an x and a y that's true about the line that looks like this. Here's the x and the y. You've got x and you've got y. X has a value of -1, y has a value of 2. Y has a value of 2 equals, well, we don't know a, and we know that x is worth -1. To figure out what a is, you can just undo using inverse operations. If we divide -1 on both sides, we'll find that a has a value of -2. Sweet. Now, we still have to write the variation equation. So we know it always has the form y equals some number with x. That number we just found to be -2. Y equals -2x. Well, if that's true, if y equals -2x, and x has a value of 30, we can figure out y pretty easily. Y equals -2 times 30. So it looks like if x was 30, y would have to be -60. Ja feel? Friends, here's an example much like the one I just did. And it says, if a graph of an equation passes through 4, 6, write the direct variation equation for that given line and find the value of y if x is 24. Good luck. Pause the video so you can see the question. Bye.